All right, folks, now as the fifth lesson in our quadratic equations unit, we're going to take a look at applications. And in particular here, we're going to go over a couple of examples, and we'll see how working through these examples, we might be able to put together a few skills that we can then use in other applications. So our first example here, we have a basketball. The path of this basketball after it's thrown from a height of 1.5 meters. The path can be given by the equation h equals negative 0.25 d squared plus 2d plus 1.5. Here, h represents the height in meters, and d represents the horizontal distance in meters. So that means it's like a ball is being thrown from 1.5 meters. So we'll say 1.5 meters is here from the ground, right? And it's being thrown up and across. And so we're referencing the height of this basketball against the distance it goes across. Now, the first question asks, how far has the ball traveled horizontally when it lands on the ground? Well, if we're looking at where it lands on the ground, if it lands on the ground, it's being thrown like this. We're looking for this distance, right? The distance from where it started to where it lands on the ground. Well, where it lands on the ground, that means that its height equals 0. If its height equals 0, what we're looking for are the roots, right? Height equals 0, we're looking for the roots. So if we're looking for the roots, we know how to handle something like this. We plug this into our quadratic formula. First, we need, so our a term equals negative 0.25, b equals positive 2, c equals positive 1.5. Fantastic. So we've set h equal to 0, and that is 0 equals 0.25 d squared plus 2d plus 1.5. So we substitute that into our quadratic formula. Substitute this, rather, into our quadratic formula. Where we are looking for d. So d equals negative b, this time, well, negative b plus or minus the square root of b squared minus 4ac. I'm hoping we're getting faster and faster at remembering this here, all divided by 2a. Now, d equals negative 2 plus or minus the square root of 2 squared minus 4 times a, which is negative 0.25 times c, which equals 1.5, all underneath the square root sign, and all divided by 2a, that's 2 times negative 0.25. Fantastic. So we'll keep right on going. That is negative 2 plus or minus the square root. We can start simplifying this here. 2 squared, that's 4, minus 4 times negative 0.25. If you can do this in your head, that's great. If you need a calculator, that's okay too. That's 4 plus or minus 1.5, sorry, plus 1.5, and it's plus 1.5 because we have this second negative sign in there. Underneath the square root, divided by 2a, this is 2 times negative 0.25, so that is negative 0.5. Fantastic. We'll keep pushing on forward here. So that equals negative 2 plus or minus the square root of 5.5 divided by negative 0.5. And then we can start, we can break this apart. So our first solution will be d equals negative 2 plus root 5.5 divided by negative 0.5. And our second solution, let's see, we'll go over top. Our second solution here will be d equals negative 2 minus the square root of 5.5, all divided by negative 0.5. So that's great. We'll plug these into our calculators right now. So that's negative 2 plus the square root of 5.5 divided by negative 0.5. We can't forget that negative in there. So our first one we find that equals negative 0.69. and rather we'll round that negative 0.7. That's approximate. And then our second solution, we come up with if we round it, it comes up to 8.7. Well, now we have two solutions. We need to ask ourselves which ones, again, both were rounded, which solutions here make sense within the context of the problem. Well, if we ask ourselves what the question was asking, if we remind ourselves, how far has the ball traveled horizontally? Then a negative answer doesn't really make sense. If it can't travel negative 0.7, that would have happened before the throw even happened. That doesn't really have any context. So this is, since it's negative, it's inadmissible. Inadmissible. Meaning that's not going to be a part of our answer. Our final answer lies right here. So therefore, the ball travels 8.7 meters. We need to bring the units in here before landing. Good. Now let's jump right on forward. We'll keep right on going. So now we need to find the horizontal distance when the basketball is at a height of 4.5 meters above the ground. If it's at a height of 4.5 meters, that means h equals 4.5. We know how to work with this. That means we're substituting h equals 4.5 into our equation. So that is h equals negative 0.25 d squared plus 2d plus 1.5. Now we're substituting, excuse me, 4.5 into the left-hand side. Even better, I can take that h out, put in the 4.5. That's awesome. Now we need, if we're going to try and find answers to this, we need everything to be on the right-hand side or everything to be on the same side so that we can use our quadratic equation. Or our quadratic formula. So we can subtract 4.5 from each side, leaving us with 0 on the left, minus 0.25d squared plus 2d plus 1.5 minus 4.5. Well, 1.5 minus 4.5, that equals negative 3. So we can put that in there. Minus 3. And that's great. Now we're substituting this into our quadratic formula. So here I have a equals negative 0.25, b equals 2, c equals negative 3. That's great, into our quadratic formula. Our quadratic formula, again, I'm hoping we're getting a little bit more comfortable using this. So that is, here we're looking for d. d equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Awesome. So negative b, well, that's going to give us negative 2. Here, let's share the screen here. Negative 2 plus or minus the square root of 2 squared minus 4 times a, which equals negative 0.25. times c, which equals negative 3. That's under the square root, and then everything is underneath 2 is over 2a. a here equals negative 0.25. Working on forward, we're simplifying this. So negative 2 plus or minus the square root of 4 minus 4 times negative 0.25 times negative 3. If you can do this in your head, that's great. That's minus 3. Divided by 2 times negative 0.25, that is negative 0.5. Awesome. Even further, negative 2 plus or minus the square root of 1 divided by negative 0.5. Now we need to ask ourselves the square root of 1. That is something squared that could equal 1. That's nice and easy. The square root of 1 just equals 1 itself. So negative 2 plus or minus 1 divided by negative 0.5. And that's great. We can use that into our, to give us our two solutions. So our first one, d equals negative 2 plus or minus, negative 2 plus 1 divided by negative 0.5. And our second solution here, will be d equals -2 minus 1 divided by -0.5, and that's great. So here I'm working with -1 over -0.5 is equals 2. Other solution, -2 minus 1, that's -3 divided by -0.5, bringing us positive 6. And that's great. Now, since we got whole numbers here, that's an indication that we could have solved this using factoring. So if we were clever with our factoring off the start, we could have managed to avoid all of this quadratic formula. But here we are getting some nice practice with our quadratic formula. We're working with, we need to tie our concluding statement back to the question. They were asking us the horizontal distance when the ball is at a height of 4.5 meters. Therefore, the height is 4.5 meters. When the ball has traveled 2 meters or 6 meters. Well, how can we have two answers? What's happening here is, like our quick sketch with the basketball once this ball is thrown, it goes up and then it comes down, right? And it's this way down, goes up and then it goes down. So let's say 4.5 meters is right here. The ball reaches it once on its way up and once on its way down. So it can make sense here that we have two solutions. We'll keep right on going. Here we're going to try and find the maximum height of the basketball. Well, we can use a bit of a trick here. Number one, we'll notice when we found our, and let's create a bit of a better sketch right here. So let's say 4.5 meters is right here. And it's like the ball goes up and the ball goes down. Well, we know from the properties of a quadratic, if there's a point right here along our quadratic and there's a point right there along our quadratic, we can find, since they have the same height, we can find the axis of symmetry, because our axis of symmetry is going to be the same distance from each of these. Our axis of symmetry will be right in the middle. That is, it's going to be the average of both of these. Well, we can use that, and we also know, if we take it even further, if we were to imagine, we know we found a negative root that we called inadmissible. That would have been about here. Same thing, this axis of symmetry will be halfway in between our roots there. Okay, so we can go look and we can see how our quadratic formula was being used out there. And we saw that in the first problem, when we were finding the roots, we had a -2 divided by 0.5. Right? And the difference of these roots, one root was plus 5.5 away from there. The other was negative 5.5, away from there. The other one was negative the square root of 5.5 away from there. And that kind of indicates to us that the rest of this problem, if we ignore what we've learned is our square root with our discriminant inside. If we ignore that, then if we look here, I have a negative b over 2a. That's going to give me my axis of symmetry. Okay, that's going to be 100% my axis of symmetry. Well, I recognize that that's the same thing that I was working with in the second part of this problem as well, right? Negative b over 2a. Negative b over 2a, that's where it comes from. That is our axis of symmetry. So we can use that right here. We can use that right here to find the axis of symmetry. Our axis of symmetry, d equals negative b over 2a. Well, that's great. Negative b equals -2 divided by 2a. That's 2 times negative 0.25, and that's great. -2 over negative 0.5, just as we were expecting. So this -2 over negative 0.5, that is positive 4. So positive 4, where d equals positive 4, that's our axis of symmetry. And we know if we're trying to find the maximum height of this basketball, we can use this axis of symmetry. That's the x-coordinate of our vertex. The maximum height, that'll be the y-coordinate. So we can find that y-coordinate by substituting our axis of symmetry into our equation. So our equation, h equals negative 0.25 d squared plus 2d plus 1.5. That equals negative 0.25 times 4 squared plus 2 times 4 plus 1.5. Nice and easy. That's negative 0.25 times 16 plus 2 times 4. That equals 8 plus 1.5. Nice and easy. If you can do this part in your head, that's great. That is negative 4 plus 8 plus 1.5, leaving us here with 5.5. So therefore, the maximum height of the ball is 5.5, and again, we need our units in here, 5.5 meters. Now, I'm hoping this gave us a few skills that we can use in particular when we're working with some projectile motion, when we're working with the motion of a ball or of something falling or flying through the air. We'll keep going. We can also use quadratics sometimes to model something like population growth. Now, in this particular case, we're given the population growth of Ontario since 1900. Okay, so T is the number of years since 1900. P is our population in hundreds of thousands. Okay, so here we're going to use this model to find Ontario's population in 1925. Well, in 1925, since T is the number of years since 1900, that means that T equals 25. So we'll write set T equals 25, and we'll find P. So P equals 0.007 times now 25 squared plus 0.196 times 25 plus 21.5. Nice and easy. Now we can, if we do something like this, if we're handling numbers like this, we're going to be working with our calculator. So if we use our calculator here, you can try it on your own. You should find P equals 30.775. Now, if P equals 30.775, that means that we're working with 30-ish times 100,000. Well, that means that we're working in the millions. So therefore, Ontario, and if you're not sure on that, you can double check with your calculator. Therefore, Ontario's population was 3.0775 million in 1925. And we'll push on forward to the second part of the problem. Here we're asking, when will Ontario's population reach 15 million people? So you'll notice how the question compares. The first time the question was asking what was the population. That's a much more straightforward problem. We just find our value for t, and we solve for p. This time we're finding our value for p, so we're setting p equal to 15 million. That's 150 times 100,000. And then we're substituting that into our initial equations. Now we're working with 150 equals, let's see here what that equation was. There we are, 150 equals 0.007 t squared plus 0.196 t plus 21.5. Fantastic. Now that we have that, we can push forward. Again, we need to isolate well, we need to find a 0 on one side of our equal sign before we can handle our quadratic formula or factoring if it is factorable. So we need to subtract 150 from each side. So that is our left side, we're subtracting 150, leaving us with just 0. And we subtract, maybe I'll write that, in another color here for us. Fantastic. Our left-hand side leaves us with 0. Our right-hand side, 0.007 t squared plus 0.196 t plus 21.5 minus 150. So that's minus 128.5. Fantastic. Now we have standard form. This is a quadratic equation. We know how to handle this. We can substitute a equals 0.007, b equals 0.196, and c equals negative 128.5. Substitute all of these into our quadratic formula. Right, so now we're working with t equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, that is negative b, so negative 0.196 plus or minus the square root of b squared. We can see this is going to get pretty ugly pretty quickly. Plus or minus the square root of 0.196 squared minus 4 times a, which is 0.007, times c, negative 128.5. That part's beneath the square root. The entire thing is divided by 2 times a, well, a equals 0.007. That's great. Now we can start simplifying it. We can use our calculator here if needed. We're working with negative 0.196. And then I'd like you to try into your calculator, please. You're going to practice it all right here. We'll substitute that into our calculator. If you do that, you should get the square root of 3.64. That's approximate, so we'll put a dot above our equal sign. All divided by 0.014. Now from here, we are given, let's make that look a little bit nicer. From here, we're given 2 solutions, right? So our first solution, t equals negative 0.196 plus the square root of 3.64. all divided by 0.014. And our second solution will be t equals negative 0.196 minus the square root of 3.64. Again, all divided by 0.014. So we'll plug these into our calculator. Good, and we're working with 122 years here, 122 years on the left side, and on the right side, negative 150 years. Well, if we're working here, we know a negative time is inadmissible. So that means that Ontario's population will reach, and we'll double back to that question here, 15 million people. 15 million people, 122 years after um, 1990, which is in the year 2022. There you are. So I'm hoping this gave you some skills as well, working with population models.